Imagine a magnetic powder keg hovering on the solar surface right now, twisted so violently that a single snap could trigger X-class solar flares, blinding HF radio and hammering satellite orbits across Earth. Combined with thousands of incandescent streaks lighting up the night sky as Earth plows through comet dust, this week has delivered one of the most remarkable double-header cosmic displays of the year. You're listening to the Daily Space Podcast by Flarient, your daily conversation about space weather, solar activity, and cosmic events. I'm Ollie, and today is Sunday, August 23rd. Welcome to our Sunday Weekly Roundup. Every Sunday, we step back from the minute-by-minute updates to analyze the biggest stories, most significant space weather phenomena, and fascinating astronomical developments that unfolded over the past 7 days. Before we dive into our weekly top 5 countdown, let's take a quick look back at a memorable cold open moment in space history. On this date in space weather history, early researchers and telegraph operators were astounded by unexpected surges in Earth currents caused by solar activity, demonstrating early on how interconnected our planet's technological network is with the magnetic temperament of our local star. Back in those days, telegraph machines would spark and transmit messages without batteries connected at all. It was one of the earliest reminders that when the sun sneezes, Earth feels the tickle in its electrical wires. Now, let's turn to our top 5 stories of the week. Coming in at number 1 on our weekly review is the formidable evolution of Sunspot 4513. Throughout this week, solar observatories have been keeping a locked eye on active region Sunspot 4513. What makes this sunspot so fascinating and potentially troublesome is its magnetic classification. It has developed into a complex beta-gamma-delta magnetic topology. In plain English, that means magnetic field lines with opposite polarities are squeezed exceptionally close together within the same sunspot group. When opposing magnetic fields are forced into tight quarters like that, they become tangled and unstable. Eventually, through a process called magnetic reconnection, those lines snap and reconnect, releasing immense explosions of energy across the electromagnetic spectrum. What makes Sunspot 4513 particularly crucial right now is its geometric position. It sits directly in the strike zone of the solar disk facing Earth. If an X-class flare erupts from this spot, the radiation arrives at Earth in just over 8 minutes, ionizing the upper atmosphere and triggering potential high-frequency radio blackouts and satellite degradation. Furthermore, if that eruption launches a fast-moving coronal mass ejection, or CME, aimed squarely at us, that plasma cloud could slam into Earth's magnetosphere within 2 to 3 days. Moving on to our second major story of the week, the breathtaking peak of the Perseids meteor shower. While solar physicists were watching the sun's surface, night sky observers around the world were treated to a splendid night show. The Perseids reached their annual peak intensity this week, delivering zenithal hourly rates approaching 100 meteors per hour in dark sky areas. Where do these shooting stars actually come from? They are bits of orbital debris left behind by Comet 109P Swift-Tuttle. Every August, Earth's orbital path intersects this dusty trail. Tiny particles of ice and dust, many no larger than a grain of sand, strike Earth's atmosphere at blistering speeds of roughly 60 kilometers per second. At those speeds, friction heats the air molecules surrounding the particle, producing the brilliant incandescent trails we call meteors. It was an incredible spectacle for stargazers worldwide. Our third major story of the week takes us into planetary physics and cosmic defense, understanding why asteroids lack atmospheres and monitoring close NEO passes like Asteroid 2026PX. Earlier this week, space scientists highlighted key dynamics regarding small bodies in our solar system. A common misconception in sci-fi is that large space rocks might harbor wisps of gas or dust clouds. In reality, asteroids are completely airless voids. The fundamental gatekeeper here is gravity. To hold onto gas molecules, a celestial body needs sufficient mass to generate strong gravitational pull. Even for sizable near-Earth asteroids, the escape velocity is extremely low, often no faster than a light jog. Any gas molecules on the surface are lost almost instantaneously into the vacuum of space. On top of that, the continuous solar wind, streaming outward at hundreds of kilometers per second, strips away any loose particles or gas that might temporarily form around these bodies. This week, tracking systems also kept tabs on Asteroid 2026 PX as it made a close, safe transit near Earth. Monitoring these pristine remnants from the early solar nebula gives us valuable insights into planetary accretion and planetary defense. Coming in at number 4 on our weekly roundup is the delicate atmospheric phenomenon of Noctilucent cloud observation. These night-shining, electric blue clouds reside roughly 80 kilometers above the Earth's surface, right in the mesosphere at the boundary of space. Unlike aurorae, which are driven by solar particle collisions with oxygen and nitrogen in the thermosphere, Noctilucent clouds depend on terrestrial atmospheric dynamics and summer mesospheric freezing conditions. Microscopic ice crystals accumulate around tiny specks of meteor dust. When the sun is just below the horizon, it illuminates these ultra-high clouds from underneath, glowing brightly against twilight skies. Researchers track these clouds carefully because subtle changes in their frequency and density act as sensitive indicators of mesospheric temperature trends and high-altitude atmospheric circulation. Rounding out our top 5 stories is a comprehensive look at solar cycle 25 and solar flare dynamics. Solar flares are a routine feature of our star's 11-year cycle. As solar cycle 25 continues its progress, understanding the classification scale from A, B, and C up to M and X class is essential for infrastructure managers. Each letter on that flare scale represents a tenfold increase in energy output. While lower-class flares pass almost unnoticed, major M and X flares directly disrupt ionospheric radio propagation, GNSS signal accuracy, and satellite drag in low Earth orbit. By analyzing past historical archives alongside current activity, researchers continue refining models to give operators advance warning before geomagnetic storms hit critical hardware. Now, let's look at the week ahead in space weather and astronomy. Over the next 24 to 72 hours, all eyes remain focused on Sunspot 4513. If this unstable region unleashes an X-class flare, expect rapid proton flux increases and potential HF radio blackouts. Current background solar wind speed is around 442 km per second, which is relatively calm, but the BZ component of the interplanetary magnetic field remains crucial to watch. If BZ turns strongly southward after a CME arrival, geomagnetic activity could ramp up rapidly. Additionally, keep an eye out for upcoming planetary alignment milestones as Mercury approaches its greatest elongation west later in the season, offering fantastic early morning viewing opportunities. Time now for our weekly fact-check segment where we set the record straight on recent viral myths circulating online. First claim, a viral conspiracy asserts that humans are being secretly abducted and teleported to underground bases on Mars for forced labor. Our verdict on this claim is completely false. There is zero evidence supporting off-world human abductions, functional teleportation technology, or underground Martian facilities. NASA's fleet of robotic orbiters, landers, and rovers, along with official records analyzed in government reviews, have found no signs of human presence, industrial infrastructure, or teleportation systems on Mars. The claim is pure science fiction. Second claim, viral posts claim a rogue planet named Nibiru is on an imminent collision course with Earth and that global agencies are hiding it. Our verdict is also entirely false. Any planet-sized object entering the inner solar system would create easily measurable gravitational perturbations on planetary orbits and be visible to millions of amateur and professional astronomers worldwide. Predicted doomsday dates for Nibiru in 2003, 2012, and 2017 all passed without event. It remains a long-debunked internet myth with no scientific foundation. That wraps up our major stories, forecasts, and fact-checks for this week. Before we go, here are a few quick ways to stay connected with us. Be sure to visit flarient.com for live space weather data, real-time KP index tracking, aurora forecasts, and interactive dashboards. It's the official website of Flarient and the best place to see what the sun is doing right now. Don't forget to subscribe to the podcast on your favorite listening platform so you never miss a daily update or weekly roundup episode. Head over to flarient.com/podcast for all our past show notes, full episode transcripts, and deep dive articles. Follow Flarient across social media for real-time space weather alerts whenever solar activity flares up, and join the active Flarient community of aurora chasers and stargazers. And finally, download the Flarient app on your smartphone to get instant push notifications the moment geomagnetic storms hit. Thank you so much for listening, stay curious, and I'll catch you again tomorrow.